Howdy, my name is Colin Brandl, and I am a senior geophysics major at Texas A&M University. My research focuses on constraining the regional stress and deformation around Bonaire and the Bonaire Basin. Bonaire is an island located approximately 90 kilometers north of Venezuela. It is part of the ABC Islands, Aruba, Bonaire, and Curacao. The ABC Islands sit in the center of the Bonaire block. This distinct crustal block buffers the interaction between the South American and the Caribbean tectonic plates. The Bonaire block is bounded to the south by the San Sebastian and Oca Ancon fault systems, and to the north by the Curacao Ridge, which is a subduction zone. Previous work in this region set the goal of defining a regional tectonic framework and a regional tectonic mechanism. However, the modern stress state of the region is not well understood and is very disputed. Our data set is a 1972 USGS seismic survey that was recorded on paper. We took the paper seismic, converted it to SegWi, and loaded it into our interpretation software. Additionally, we have access to a 2016 high-res survey near shore to Bonaire. We've observed a variety of features on our seismic sections: normal faults, thrust faults, inverted normal faults, as well as strata showing periods of growth and growth pause. We interpret any feature breaking the seafloor to be representative of the modern stress regime of the region. We also interpret any feature that does not break the seafloor to be representative of a past stress regime in the region. Additionally, we have worked to correlate our survey with the work of Gorney et al. 2007 to bring over established seismic horizons corresponding to specific seismic ages. These horizons allow us to include features that may not break the seafloor, but break into the most recent sediment package from the Pliocene and Pleistocene in our recent stress interpretation. As an example, the strata from line 19's anticline shows parallel reflectors, meaning a growth pause at the seafloor. However, directly below the growth pause is a period of growth. This growth occurs within the Pliocene and Pleistocene sediments, meaning that we can include it in our recent stress interpretation. When displayed on a map, our interpretations show a distinct geographic trend. To the east, there is exclusively extensional features evidenced by normal faulting. To the west, there is exclusively compressional features evidenced by thrust and reverse faulting, as well as the growth of those anticlines. We also have interpreted a continuation of the older subsurfaced La Vela fold thrust belt, further to the east than any previous survey has shown it. Previous work in this region has always concluded that there is either a uniform stress regime or a non-uniform stress regime across the region. We interpret and conclude that the stress regime, the modern stress regime of the region, is not uniform. And we disagree with any conclusions saying the stress regime should be uniform. Our findings could support conclusions of previous regional transpression or regional block rotation. We propose a modern tectonic mechanism that combines simple shear and rotation, with the Caribbean plate driving the Bonaire block eastward while the Bonaire block drags along its southern slip strike boundary. Our future work will be to further correlate with the high resolution survey. Difficulty in this arises because the high resolution source had difficulty penetrating the hard bottom seafloor. As well, the scales of the surveys are very different. We also would like to examine any other possible tectonic mechanisms that could cause this deformation, as well as refine our proposed mechanism. Thank you for your time, and giggle.